Okay, so for today, we're going to have a discussions about inferential statistics, no? So statistics has a significant part in the field of data science, no? It helps us in the collection, analysis, and representation of data either by visualization or by numbers into a general understandable format. Generally, we divide the statistics into main branches, which one are descriptive statistics and inferential statistics. So population in sample, before discussing the inferential statistic, let us see the population in sample. So population contains all the data points from a set of data. So it is a group from where we collect the data, while a sample consists of some observations selected from the population. So the sample from the population, measurable characteristics such as mean, standard deviation, standard deviation, and others are so-called parameters, while sample measurable characteristic is known as statistics. So descriptive statistics describe the important characteristic of data by using mean, median, mode, variance, and others. It summarizes the data through numbers and graphs. In inferential statistics, we make an inference from a sample about the population. The main aim of inferential statistics is to draw some conclusions from the sample and generalize them for the population's data. Let's say, for example, if we have to find the average salary of a data analyst across Philippines, there are two options. The first option is to consider the data of data analysts across Philippines and ask them their salaries and take an average. The second option is to take a sample of data analysts from the major IT cities in the Philippines and take their average and consider that for across Philippines. The first option is not possible as it's very difficult to collect all the data of data analysts across in the Philippines. It is time consuming, right? As well as costly. So to overcome this issue, we will look into the second option to collect a small sample of salaries of data analysts and take their average as Philippines average. No, this is the inferential statistics where we make an inference from a sample about the population. So in inferential statistics, our presenter will discuss probability, distribution, and hypothesis testing. Okay? So to give us more details about the topic, let us all welcome our presenter. Go ahead.
Good morning everyone, my name is Jello Flores and I'm here to report about the inferential statistics. Inferential statistics allow us to determine the probability that a sample mean represents the population from which it was drawn. Using probability to determine whether it is likely that a particular sample or test outcome is representative of the population. Experimental versus the control group. Experimental is a group that is tested or given a treatment. The control group is a group identical to the experimental group that is not given a treatment. Both drawn from the same population and it should have the same mean. If drug is not effective, then we should expect after the experiment, the sample mean of the experimental group would still be the same as the sample of the control group. But if after the experiment, the sample mean of experimental group is different from the sample mean of the control group, then the intervention had an effect, and it's called the hypothesis testing. Hypothesis is a testable prediction about a real-world phenomenon. Experimental hypothesis, a starting point that will be accepted or rejected by examining the evidence that supports or contradicts it. Experimental hypothesis. Null hypothesis. The sample mean is the same as the population mean. Any differences are due to chance. Alternative hypothesis. The sample mean is not the same as the population mean, and any differences are due to an effect. We have here a sample population with high blood pressure. The diastolic blood pressure of a population is 102. The normal pressure diastolic blood pressure is under 80. We draw a sample, which is the sample 1, from that population, and we expect that the sample mean will have the same blood pressure as the population which they are drawn. And as expected, they they have high blood pressure. The diastolic of the population is 102. The diastolic of the sample is 102.5. Those numbers are the same. There is a random variation, but the sample mean represents the population mean. So it's still pretty close. So the variation we see is due to chance. We draw another sample from the population, and they also have high blood pressure. Their diastolic blood pressure is 101. The sample mean is different from the population mean, but the variation is due to chance. Then we then we assign the first example as the control group and the sample 2 as the experimental group. To lower the blood pressure, we give the experimental group a new drug to lower their blood pressure and keep them on the drugs for 2 months, then measure the blood pressure again. After the treatment, we find the control group mean changes from 102.5 to 101.2, which is still high blood pressure and still represents the population mean. But the experimental group sample mean is different from what it was 2 months ago. Before experiment, the diastolic blood pressure is 101, but now it is 86. Now the sample mean represents a different population, a population of people with close to normal diastolic blood pressure, which means that the drug had an effect.
Good morning, everyone. My name is Nina May Uy, and I'm going to be discussing about the topic confidence intervals. So, confidence intervals are a statistical tool that provides a range of values that is likely to contain the true value of a population parameter with a certain degree of confidence. In this report, we will cover the definition of a confidence interval, why they are important, and how they are calculated. For the definition of a confidence interval, a confidence interval is a range of values that is likely to contain the true value of a population parameter with a certain degree of confidence. For example, if we have 95% confidence interval for the population mean, we are 95% confident that the true mean falls within this interval. Now, for calculating a confidence intervals are based on sample data and a level of confidence, which is usually 95% or 99%. To calculate a confidence interval, we use the formula point estimate plus or minus margin error. The point estimate is the sample statistic used to estimate the population parameter, such as the sample mean. The margin of error reflects the variability of the sample statistic and depends on the sample size and level of confidence. In interpreting confidence interval, a confidence interval is a range of values that is likely to contain the true population parameter with a certain degree of confidence. The confidence level reflects how often the procedure used to construct the interval will produce intervals that contain that true parameter. For example, if we construct 195% confidence intervals, we expect 95 of them to contain the true parameter. It is important to note that the confidence level only refers to the procedure used to construct the interval and not to the probability of the true parameter falling within the interval. Moving on to the factors affecting the width of a confidence interval. The width of confidence interval is influenced by several factors. First is the sample size. Larger samples result in narrower intervals because there is less variability in the sample statistic. As the sample size increases, the sample mean becomes more accurate estimate of the population mean, resulting in a narrower confidence interval. Next is the level of confidence. Higher confidence levels result in wider intervals because there is more certainty that the true parameter falls within the interval. For example, a 99% confidence interval will be wider than a 95% confidence interval for the same sample. Lastly, the variability of population. More variability in the population results in wider intervals. This is because a more variable population produces a wider range of sample statistics, resulting in a wider confidence interval. In conclusion, understanding the interpretation of confidence interval and the factors affecting its width is crucial in statistic analysis. A confidence interval is not a probability that the true parameter falls within the interval, but rather reflects the degree of confidence in the procedure used to construct the interval. The width of the confidence interval is affected by sample size, level of confidence, and variability of the population. Confidence intervals are commonly used for the following purposes: estimating population parameters such as means, proportions, and variances, comparing two or more population parameters, and lastly, testing hypotheses about population parameters. Now, to conclude and summarize the topic, confidence intervals are a powerful tool for estimating population parameters based on sample data. They provide a range of values that is likely to contain the true parameter with a certain degree of confidence. Factors that affect the width of interval include sample size, level of confidence, and variability of the population. Confidence intervals are commonly used in statistics and data analysis to make inferences about population parameters, and understanding their interpretation is crucial for making informed decisions based on statistical analysis. Before ending the discussion, I'll show the formula for calculating confidence interval with an example. Suppose a researcher wants to estimate the mean height of all adult males in a certain city. The researchers collects a random sample of 100 adult males and finds that the mean height in the sample is 180 centimeter. The researcher can use inferential statistics to calculate a 95% confidence interval for a true population mean height. Before proceeding to the solution, this table shows the equivalent confidence level and its safe value. Formula for calculating confidence interval. The formula for calculating the confidence interval for the mean is Ci equals x bar plus minus z times parenthesis s divided by square root of n, close parenthesis, where x bar is the sample mean, s is the sample standard deviation, n is the sample size, z is the z-score corresponding to the level of confidence, and plus minus indicates the range of the values. Now, if we apply the formula using a z-score of 1.96 for a 95% confidence interval, the researcher can calculate the confidence interval as shown. This means that the researcher can be 95% confident that the true proportion mean height falls between 177.04 cm and 182.96 cm. Another example, a poll conducted to estimate the proportion of adults in a country who support a certain political candidate. The pollsters take a random sample of 1,000 adults and find that 55% of them support the candidate. Using inferential statistics, they can calculate a 99% confidence interval for the true proportion of adults who support a candidate. Another formula for calculating the confidence interval is for the proportion. The formula is Ci equals P plus minus Z times square root of parenthesis P parenthesis 1 minus P divided by N, where P is the sample proportion, N is the sample size, Z is the z-score corresponding to the desired level of confidence, and plus minus indicates the range of the values. Now, applying the formula for solving the proportion using a z-score of 2.58 for a 99% confidence interval, the pollsters can calculate the confidence interval as shown. This means that the pollster can be 99% confident that the true proportion of adults who support the candidate falls between 0.513 and 0.587.
One sample t-test. A one-sample t-test is a statistical test used to determine whether a sample mean is significantly different from a hypothesized population mean when the population standard deviation is unknown. In other words, it helps to determine whether a sample comes from a population with a known mean. This test is useful in many fields, including psychology, education, and business. For example, suppose that we want to know whether the average age of the population is 35. We randomly select 20 individuals from the population and find their ages to be 38, 34, 32, 39, 41, 36, 37, 33, 40, 31, 35, 37, 36, 38, 33, 39, 40, 34, 35, and 36. We can use the one-sample t-test to determine whether the sample mean is significantly different from the hypothesized population mean of 35. We begin by stating the null and alternative hypothesis. The null hypothesis is that there is no significant difference between the sample mean and the population mean. The alternative hypothesis is that there is a significant difference between the sample mean and the population mean. The null hypothesis is equals to 35, and the alternative hypothesis is not equal to 35. Next, we must choose a level of significance, denoted by alpha. The level of significance is the probability of making a type I error, which is rejecting the null hypothesis when it is actually true. A commonly used level of significance is A is equals to 0.05. We can calculate that statistics using the following formula. T is equal to X minus mu over S divided by N, where X is the sample mean, mu is the hypothesized population mean, S is the sample standard deviation, and N is the sample size. First, we calculate the sample mean. x is equals to 38 plus 34 plus 32 plus 39 plus 41 plus 36 plus 37 plus 33 plus 40 plus 31 plus 35 plus 37 plus 36 plus 38 plus 33 plus 39 plus 40 plus 34 plus 35 plus 36 divided by 20 is equals to 36.1. Now, we calculate the sample standard deviation. S is equal to square root 38 minus 36.1 raised to 2 plus 34 minus 36.1 raised to 2 plus so on and so forth plus 36 minus 36.1 raised to 2 is divided by 20 minus 1 is equals to 2.661. Now, we calculate the test statistic. T is equals to 36.1 minus 35 over 2.661 divided by square root 20 is equals to 2.48. The degrees of freedom df for a one sample t-test is n minus 1, where n is the sample size. In this case, df equals to 19. We can use a t-distribution table or calculator to find the critical value for our level of significance and degrees of freedom. For a two-tailed test with A is equals to 0.05 and DF is equals to 19, the critical value is positive negative 2.093. We compare the calculated test statistic with the critical value. If the calculated test statistic is greater than the positive critical value or less than the negative critical value, we reject the null hypothesis in favor of the alternative hypothesis. Since our calculated test statistics is t is equals to 2.48 is greater than the positive and critical value is 2.093, we reject the null hypothesis and conclude that there is a significant difference between the sample mean and the hypothesized population mean. We can conclude that the sample mean age is significantly greater than 35. Two-sample t-test. A two-sample t-test is a statistical test used to compare the means of two independent samples. It is used to determine whether there is a significant difference between the means of two populations from which the samples were drawn. The test assumes that the two samples are independent and normally distributed with unknown but equal populations variances. For example, suppose that we want to compare the average weight of apples produced by two different farms. We randomly select 20 apples from farm A and 20 apples from farm B and weigh them. The weights of the two samples are given below. We can use the two-sample t-test to determine whether there is a significant difference between the mean weights of the two farms. Farm A 3.2, 3.5, 2.9, 2.7, 3.1, 3.3, 3.0, 3.4, 3.2, 2.8, 3.0, 3.1, 2.9, 3.2, 2.8, 3.1, 3.5, 3.0, 3.3, 3.1. Farm B 3.7, 3.5, 3.8, 3.2, 3.1, 3.3, 3.6, 3.5, 3.7, 3.1, 3.4, 3.5, 3.8, 3.6, 3.7, 3.2, 3.4, 3.6, 3.3, and 3.5. We begin by stating the null and alternative hypothesis. The null hypothesis is that there is no significant difference between the mean weights of the two farms. The alternative hypothesis is that there is a significant difference between the mean weights of the two farms. The null hypothesis 1 is equals to 2. The alternative hypothesis 1 is not equals to 2. Next, we must choose a level of significance, denoted by alpha. The level of significance is the probability of making a type I error, which is rejecting the null hypothesis when it is actually true. A commonly used Level of significance is A is equals to 0.05. The sample means can be calculated by adding up all the values in each sample and dividing by the sample size. x1 is equals to 3.2 plus 3.5 plus 2.9 plus 2.7 plus 3.1 plus 3.3 plus 3.0 plus 3.4 plus 3.2 plus 2.8 plus 3.0 plus 3.1 plus 2.9 plus 3.2 plus 3.1 plus 3.5 plus 3.0 plus 3.3 plus 3.1 divided by 20 is equals to 3.09. x2 is equals to 3.7 plus 3.5 plus 3.8 plus 3.2 plus 3.1 plus 3.3 plus 3.6 plus 3.5 plus 3.7 plus 3.1 plus 3.4 plus 3.5 plus 3.8 plus 3.6 plus 3.7 plus 3.2 plus 3.4 plus 3.6 plus 3.3 plus 3.5 divided by 20 is equals to 3.47. The sample's standard deviations can be calculated by finding the square root of the sample variances. The sample variances can be calculated by summing and squared deviations from the mean and dividing by the sample size minus 1. S1 square root 3.2 minus 3.09 squared plus 3.5 minus 3.09 squared plus 2.9 minus 3.09 squared plus 2.7 minus 3.09 squared and so on and so forth divided by 20 minus 1 is equals to 0.2036. S2 is equals to square root 3.7 minus 3.47 squared plus 3.5 minus 3.47 squared plus 3.8 minus 3.47 squared plus 3.2 minus 3.47 squared and so on and so forth is divided by 20 minus 1 is equals to 0.2106. The pooled standard deviation is an estimate of the population standard deviation, assuming that the two populations have equal variances. It is calculated using the sample standard deviations and sample sizes as follows. SP square root 20 minus 1 times 0.2036 squared plus 20 minus 1 times 0.1779 squared divided by 20 plus 20 minus 2 is equals to 0.1905. The T statistics is a measure of how many standards error in the sample means are apart. It is calculated as follows. T is equals to 3.09 minus 3.47 divided by 0.1905 times square root 1 divided by 20 plus 1 divided by 20 is equals to negative 3.192. The degrees of freedom are calculated as follows. df is equals to 20 plus 20 minus 2 is equals to 38. The p-value is the probability of observing a t-statistics as extreme as the one calculated. Assuming that the null hypothesis is true, the p-value can be found using a t-distribution table or using statistical software. For a two-tailed test at a is equals to 0.05 with 38 degrees of freedom, the p-value is approximately 0.0025. Since the p-value is less than a, we reject the null hypothesis. There is sufficient evidence to conclude that the mean weight of the apples produced by Farm A is significantly different from the mean weight of apples produced by Farm B. Based on the analysis, we reject the null hypothesis that the mean weights of the two farms are equal and conclude that there is a significant difference between the mean weights of apples produced by the two farms. The t-statistics is negative 3.192 with 38 degrees of freedom, and the p-value is approximately 0.0025 at a is equals to 0.05. These results suggest that the farm B produces apples that are heavier on average than those produced by Farm A.
Before we move on to the next topic, I'm Carla Socia, and I will be the presenter for an introduction to ANOVA. For the overview, ANOVA, or analysis of variance, is a statistical technique used to compare means across multiple groups. It helps us determine whether there is a significant difference between the groups. It is a powerful tool for making inferences from data and can be used in various fields such as psychology, biology, and business. The basic idea of ANOVA is to compare the variance between groups to the variance within groups. If the variance between groups is larger than the variance within groups, it suggests that there are differences between the groups. To test for statistical significance, we use an F-test, which compares the significance variance between groups to the variance within groups. In order to conduct an ANOVA, we need to normally distributed data and equal variances between groups. We also need to make sure that the groups are independent and that there are no outliers or influential data points that could affect our results. Assumptions of ANOVA. To ensure accurate results, it is crucial to verify whether ANOVA assumptions are satisfied prior to usage. Normality, homogeneity of variances, and independence are among the key assumptions that must be assessed. Inaccurate results may occur if these assumptions are not met, and there are various tests that can be employed to verify them. One-way ANOVA is used when we have one categorical variable and one continuous variable. It helps us determine if there is a significant difference between the means of the groups. Post-hoc tests can be used to identify which groups are significantly differently from each other. It is a statistical method used to compare the means of three or more groups. In this presentation, we will explore the significance of one-way ANOVA and how it can be used to draw conclusions from real-world examples. Assumptions of one-way ANOVA. Before we dive into using one-way ANOVA, it is important to understand its assumptions. These include normality of data, homogeneity of variance, and independence of observations. Violations of these assumptions can lead to inaccurate results. Hypothesis testing with one-way ANOVA. One-way ANOVA is used to test the null hypothesis that all group means are equal against the alternative hypothesis, that is, at least one group mean is different from the others. If the p-value is less than the significance level, we reject the null hypothesis and conclude that there is a significant difference between the groups. Let's take a look for this example. A company wants to test the effectiveness of three different training methods on employee productivity. The one-way ANOVA test shows the p-value of 0.01, which is less than the significance level of 0.5. We reject the null hypothesis and conclude that there is a significant difference between the three training methods. While one-way ANOVA is a powerful statistical method, it has some limitations. It can be only used to test one independent variable and assumes that the groups are independent and have equal variances. Additionally, post-hoc tests can be necessary to determine which groups are significantly different from each other. Two-way ANOVA is used when we have two categorical variables and one continuous variable. It helps us determine if there is a significant interaction between two variables. This is useful for understanding how different factors affect the outcome. It is also a versatile statistical method used to study the interactions between two factors, elucidating how each one affects a responsive variable. Suitable for more complex ideas, This technique can provide valuable insights into a relationship among multiple variables. By incorporating real-world examples, these presentations aims to illustrate best practices for using two-way ANOVA, helping you to better understand and fully utilize its full potential. In factorial design, you'll consider how two or more factors affect a responsive variable. This type of experiment aims to investigate the effects of different combinations of the factors on the responsive variable. By doing so, you can determine the main effects and interactions between the factors. By understanding the setup and interpretation of factorial designs, you can draw the conclusions and make decisions based on the results obtained. Hence, it is a crucial tool for researchers, businesses, and organizations that want to determine the best course of actions based on different variables and factors. Main effects. A main effect refers to the impact of one of the factors on the response variable when the other factor is held constant. In other words, it is the average effect of one factor on the response variable across the levels of other factors. Understanding how to identify and properly interpret main effects is crucial for conducting accurate and insightful data analysis using two-way ANOVA. Interaction effects. An interaction effect is a critical aspect to consider in a statistical analysis because it provides valuable insights into the relationship between different factors and their impact on the outcome variable. By examining how one factor's effect changes depending on the levels of another factor, researchers can gain deeper understanding on the underlying patterns and the relationships within the data. This process not only helps in making informed decisions based on the results, but can also guide the development of future research, questions, and hypotheses. The assumptions of two-way ANOVA must be met to ensure the validity of its results. These assumptions can be checked by analyzing the residuals or through statistical tests such as Shapiro-Wilk or Levin's test. When the assumptions are not met, transformations, non-parametric tests, or alternative statistical methods can be used. Mixed ANOVA. Mixed ANOVA is used when we have one within subjects variable and one between subjects variable. It helps us determine if there is a significant difference between the means of the groups and if there is a significant interaction between two variables. This is useful for studying changes over time. That's all. Things.
Hi guys, welcome back to my channel. So for today, we will discuss one-way analysis of variance or ANOVA. So meron na akong dating video na ginawa nito. So this is an enhancement video lang naman ng lesson about one-way analysis of variance. So same lang din yung giving ko doon sa giving ko dito. So proceed tayo sa discussion. Ano nga ba yung one-way analysis of variance na yan? By definition, the one-way analysis of variance or ANOVA is used to determine whether there are any statistical significant difference between the means of three or more independent groups. Three or more. Sabihin, test of significant difference din siya. Unlike nga lang dun sa mga previous discussion natin na si t-test at z-test, they are comparing two groups lang kasi or two datas lang. Okay? Pagka lumagpas ka na sa two datas, hindi na natin pwedeng gamitin si t-test or z-test. Pwede natin gamitin kapag more than two groups na siya, three or more, that is one-way analysis of variance or one-way ANOVA. So, yun siya. So, formula for one-way ANOVA, napakadali lang, which is F value Yung iba F ratio, yung iba F lang, that is pertaining for ANOVA, which is MSBG over MSWG, which is MSBG is the mean squares of between the group, and then MSWG is the mean squares within the group. So, kung makikita ninyo, very simple lang yung formula niya kasi ratio lang between two datas lang siya. So, bago kayo, so even though napakasimple ng formula ni F value or ni ANOVA, ay bago makuha yung MSBG na yan sa MSWG o bago makarating dyan sa F-test na yan, meron kayong dadaanan ng 7 steps. So, pang 7 step tong F value na yan. So, bago makuha si ANOVA. So, therefore, meron tayong different formulas bago ka makarating dito sa very simple na formula na siya. So, ano nga ba yung 7 step na yan? Ihimay-himayin natin yan dito sa video na to. Okay? Next thing na we need to know is the decision rule. Same lang rin naman siya ng decision rule ng t-test at z-test, which is if the computed f value, the computed ANOVA is less than the critical value, sabihin nandun within the rejection region siya, accept yung HO natin doon. Same lang din sila. Kapag greater than, sabihin labas siya doon, nandun siya sa rejection region, which is reject ang HO natin. Okay? So, yun lang naman yun. Kapag less than, nandun siya sa within. Di ba? Kung makikita natin sa normal curve, within siya, nandun siya sa loob. Kaya accept natin si null hypothesis. Pero kapag greater than siya, ibig sabihin, nandun siya sa labas, nung sa normal curve natin, kung saan natin siniset yung limit, that is reject HO. Okay? So, since same lang rin siya ni t-test at z-test, meron tayong sinusunod na table for F value. So, this is the table for F value or F critical value natin. 0.05 level of significance. Ito yung value kapag 0.05. Kasi as compared sa other tables, sa F value, meron tayong dalawang degrees of freedom. DFWG, ito yun, yung within the group, and then VG or the DFV, which is the between the group, ito yun. So, mag-iiba sila ng mga values. Depende dun sa ano. So, since this lesson naman ay related sa research, which is research most commonly used is 0.05 level of significance. So, ito na lang gamitin natin table. Ito yung pinagkuhaan ko ng source na itong table na to. Pero lalagay ko na lang sa description below yung table na yan. Okay? Yung pinagkuhaan ko niyan, yung link niyan. So, kung gusto niyo maghanap, ibig sabihin, kung meron pang ibang F table or F critical table, depende sa level of significance. So, for this part, ang ginagamit ko is 0.05. Okay? So, proceed tayo dun sa problem para mahimay natin yung 7 steps. Example number 1, is there any significant difference in the administrator performance of the academic administrators when they group according to socioeconomic status? Use alpha 0.05. So, ayan, based dun sa table na gagamitin natin. So, yun nga, 0.05 ang gagamitin natin. And then, this is the data. So, meron tayong, sa academic administrator natin, meron sa kanilang, ang socioeconomic status is low, average, and high. So, ito yung mga datas na meron sila. Which is their academic performance, administrator's performance. Ito yun. So, since 3 groups yan, meron tayong low group, meron tayong average group, and high group, hindi natin pwedeng gamitin ng t-test. Since more than 3 groups, 3 groups siya, so more than 2 groups, so ang gagamitin natin is ANOVA. So, para lang makompleto yan, kailangan natin na may itong mga values na to. So, yun yan. Pero pag nag-collect kayo ng data, ito lang talaga ang data na meron kayo. So, kailangan nating kumpletuhin yung table. Okay? So, ganitong format ang pagkukumpleto nyo kasi yung mga yan ang gagamitin natin para dun sa computations natin. Okay? Una is x sub 1 squared. Sabihin nito, square lang naman natin yung mga first data natin. Okay? Lahat ng data natin dun sa first tables, which is ang first data natin or first group natin is low. Lahat ng data na yan is square natin. Yung x sub 2 squared, lahat ng data dito i-squared natin. And x sub 3 squared, lahat ng data natin sa third group, i-squared lang natin. Okay? So 1 squared, that is 1. 2 squared is 4. 2 squared is also 4. 4 and 3 squared is 9. Okay? And then so on. So fast forward tayo, that is 2 squared, that is 4, 9, 16, 25, 36, 16, 16, 16, 25, and 49. So, ini-square lang natin bawat data. Okay? Next thing is total. O, sasum up lang naman natin yan. So, sum of this, 1 plus 2 plus 2 plus 2 plus 3, that is 10. Next is 20, next is 24, next is 22, 90, and 122. Pwede nyo i-post yung video kung gusto nyo i-check kung tama yung answer, sum up ko. Ayan, pwede nyo i-correct. Grand total is, ito total lang natin. We need to total yung hindi naka-squared na data. Okay? Saka, ito total din natin lahat na naka-squared na data. So, para hindi kayo mahirapan, di yung mga total na lang yan nyo. 10 plus 20 plus 24 gives us 54. This part, 22 plus 90 plus 122 gives us 234. Take note yung dito, ina-add up lang natin lahat nung total nung hindi naka-squared. Ibig sabihin, total lang nung bawat data. Okay? And then yung kabila naman yung total nung lahat ng data. Okay? So, same rules lang rin na ginagawa natin sa other videos natin. Hindi naman lahat yung buong table na yan gagamitin natin. Meron lang tayong specific data dyan sa table na yan na gagamitin natin. Which is itong lahat ng nakabold na yan. Okay? So, yung iba dito, pwede namang ito na lang i-total nyo, huwag na ito. Same lang din naman yan. Pero nga, para mas mabilis, yun yung reason ko. Pero, kung ayaw nyo, wala nang problema. Kasi hindi naman siya kailangan. Ito lang mga kailangan. Una is the sum of the first data, which is 10. Sum of the second data, which is 20. Sum of the third data is 24. And so on yan ha. Take note groups to. So possible, mas maraming isang group, yung second group, konti, then mas marami rin yung third group. Okay lang na magkakaiba sila ng bilang. Okay? So, okay lang regardless kung ilan yung bilang ng bawat group. Basta ang nangyari, more than 3 or more groups na siya. Okay? Maging equal man yung values niyan or yung number of members each group. Nagkataon lang tong data na to ha. Magkaiba man sila ng number of each group, okay lang. Okay? So, next is the grand total. So, grand total natin, which is 54. Which is the grand total x squared, which is x sub I squared. So, yung iba, GT squared din na nilalagay. Okay lang naman yun. So, nasa yun naman para ipangalanan siya. Next is the number of sample size, which is n natin n sub 1 is 5. First group, second group, and then third group. Nagkataon lang na pare-pareha silang 5. Pero there are times or chances na magkakaiba yung bilang ng per group, okay lang yun. Pwede pa rin natin gamitin si ano ba. So, siyempre, kung magkakaiba sila ng bilang, magkakaiba rin yun nandito. Okay? So, next is n total. Ilan yung pinaka-total nilang lahat ng bawat datas natin or samples natin. Since, para madali mo magawa, di kunin mo muna yung bawat sample size ng bawat data mo or bawat group mo. Then add up mo, that is the n total. Okay? Ito lang yung mga data na kailangan natin. Okay? Yan lang yung data na kailangan natin para makapag-proceed dun sa formula. Okay? So, proceed tayo. Next is key. Key pa pala, kailangan pa pala natin ng key. Key is the number of categories. Stands for categories. Kung ilan yung group. Since ang group natin low, average, and high. So, 1, 2, 3. So, meron tayong key. Ayan, which is 3. Kung 4 groups yan, 4, and so on. Depende sa number of groups yung key na yan. Okay? So, proceed tayo. Isa-isayin lang natin, ilagay lang natin yung details dito. Proceed tayo dun sa computations, dun sa bawat step. First step is, determine the correction factor by using the formula. Ito yon, which is correction factor, which is equal to grand total squared over total number of observation, which is grand total squared over n subtotal. Okay? So which is may data tayo dyan, which is ito yun, 54 squared daw over n total, which is 15. Ayun yun. 54 squared over 15 gives us 2,916 over 15 gives us 194.4. Okay? So, kung gusto niyo i-check, wala kang problema. Try to check kung tama yung computations. Kung maraming decimal, at least 4 decimal tayo, much better. I suggest 4 decimal para at least hindi ka pa kasi the more ka na nagra-round up, lalo na dito sa part na to, 7 steps tayo. The more ka na nagra-round up, the more na lumalayo ka dun sa exact answer. Okay? So, proceed tayo. So, yan yung first step natin. Kailangan natin yung correction factor which is 194.4. Next is the total sum square. So, the SS total. So, total sum square which is the summation of x of I squared, which is ito yun, minus the correction factor. So, napakadali lang yun. 234, ito yun, minus the correction factor, which is na-compute natin doon sa una, gives us, SS total natin is 39.6. Okay? So, nakakadalawang step na tayo. Una, correction factor. Divide down natin ito dun sa total. Okay? Yung grand total natin dun sa number of observation. Yung total number of observation. Then, next step natin, yung sum ng squares, total sum of squares minus the correction factor. That is the SS total. So, proceed tayo dun sa next step. Linagay ko lang dito yung na-compute natin para kumasya. So, SS correction factor natin and SS total natin. Next step natin, third step, compute the sum of squares between the group. So, sum of square or SSBG, which is T sub I squared over N sub I minus the correction factor. T sub I is the total squared, yung sabihin yung specific total, okay, yung bawat total nun, i-squared natin over yung specific na count niya. Okay? So, it means, ganito. Sabihin, total nito ng first group natin, which is 10, over yung corresponding count niya. Okay? Corresponding count niya, ibig sabihin, may chances na kung, kunyari dito sa summation of x sub 2 mo is, ang total lang nung number of groups doon is 4, magiging 4 lang yun doon. Sabihin, depende sa corresponding total. Okay? So, 10 squared over 5 plus 20 squared over 5 plus 24 squared over 5. Ayan. Gives us, so, pwede nyo na rin dire-diretso ito. Nasa inyo naman, nasa calculator, pwede na may lagay siya sa calculator. 10 squared total. Basta, very careful lang tayo sa paglagay ng parenthesis. Okay? So, 10 squared, that is 100 over 5, that is 20, and so on. So, which is gives us a total of 215.2. Right? Pwede nyo i-post yung video, double check nyo kung sakaling doubted kayo. Okay? So, minus 194.4 is equal to 20.80. So, that is our SSBG. Next step, fourth step natin, compute the sum of squares within the group. SSWG rin, which is napakadali ng formula for SSWG, that is SS total minus SSBG. Which is SS total natin is 39.6 minus SSBG, which is 20.8, gives us 18.80. Okay? So, nakakapat na step na tayo. Pwede na tayo mag-proceed dun sa tatlong step na lang. So, lagay lang natin itong mga to, yung dalawang to dito sa given natin. So, yan. Meron na tayo na dagdagan yung given natin, nanganganak. No? Next natin is compute the degrees of freedom dun sa dalawa. Okay? Meron tayong dalawang degrees of freedom. I show ko na, diba, nung pinakita ko sa inyo dun sa table, dalawang degrees of freedom natin, which is BG and WG. Which is BG is K minus 1. K stands for number of categories or number of groups. So, which is, meron tayong 3 groups, minus 1 gives us 2. Next is N total minus K, which is 15 minus 3 gives us 12. Okay, ganun lang kadali si step 5. Lagay uli natin siya dyan. Next natin, step 6. Compute the mean square by using the formula. Okay, so, di ba sa last step ng natin, divisions lang natin to. Yung kung natatandaan nyo yung formula natin sa natin yung bawat isang yan. So, yun yung kailangan natin para makuha natin si F value. So, for MSBG, that is SSBG, 20.80 divided by DFBG, which is 2. So, that is 10.40. And then, next is for MSWG, that is 18.80 over 12. So, gives us 1.57. So, kung maraming decimal yan, pwede nyo naman i-accept yun hanggang 4 decimal. Okay? So, next natin, step 7 natin, compute for F value by using the equations. So, ito yon yung F value na natin. So, last step nga yun yung pang 7 steps natin, which is meron na tayong value dun. 10.40 divided by 1.57 gives us 6.62. So, sa final answer yan, pwede na kayo mag 2 decimal dyan. Kasi kung makikita nyo doon sa table, 2 decimal lang rin naman yung nasa table. Okay lang yun. So, yun. Again, dun sa table nga sinasabi ko, yung F critical value. So, therefore, magko-compare ulit tayo dun. So, kailangan natin ilagay ito sa table yung 6.62 na yan. So, ito na lang ang kailangan natin dito sa paglagay dito sa table na to. Okay? DFBG, nakuha natin doon, which is K minus 1, which is 2. DFWG, that is N total minus K, which is 12. And then the computed F value. Ito lang yung tatlong kailangan natin at ilalagay dito sa table. So, next is 6.62. Between the group, that is 2. Within the group, that is 12. Okay? So, ang susunod na kukunin natin is F critical value at alpha 0.05. So, pupunta tayo dun sa table. Hanapin natin dun yung position ng 2 at ng 12. So, punta tayo dyan. Ito, hanapin natin DFBG. Dito yung B. Ayan, DF sub B, which is BG yon between the group. DF sub W, which is DFWG, which is within the group. So, hanapin natin yung 2 and 12. Okay? Ayun yung 2 and 12. Hanapin natin kung saan sila nagtapat. That is 3.89. So, therefore, our F critical value is 3.89. Okay? So, proceed tayo. Balik tayo dun sa table. Ayan. Lagay natin yung table. Lagay ko na rin yung problem dito. Ayan. So, lagay natin sa table yung 3.89. Ito yung critical value natin. Okay? So, balik tayo. So, para mapakompleto natin to, same lang rin naman, punta tayo sa decision rule. Okay? Kung yung computed F value is less than F critical, accept. If the computed value is greater than F critical, reject. Since 6.62 is greater than 3.89, therefore our decision is reject the null hypothesis or reject HO. Since we reject HO, our interpretation is with significant difference. So, yung iba ang ginagawa lang with significant lang. Yung iba ay significant lang. Depende naman siguro yun sa nagpapasolve. So, sa akin kasi, stated naman dun sa given problem na difference ang hinalam. So, pwede naman lagay nyo siya. Choice nyo na yun. Okay? So, ganun lang kadali mag-compute ng F critical value. Once tama sundan mo yung 7 steps, makukuha mo na yung answer. Okay? Mabubuo mo siya. Okay? So, I provide your example number 2, pero wala na akong answer. Kayo nang bahala mag-solve. Pwede nyo ilagay sa description below kung gusto nyo mag-practice. Ayan. Para titingnan ko kung tama yung sagot nyo. Okay? So, yun, makapansin niyo dyan, iba-iba yung bilang. Okay? Iba-iba yung bilang nung first group, second group, and third group. So, therefore, may chance, iba-iba rin yung n ng bawat yan. And sub 1 nito is 6, and sub 1 nito is 5, and then x sub 1 nito is 4. Ganon din ang mangyayari niyan. Iba-iba rin yun sa computations niyo. Okay? So, that's all for this video. Thank you for watching.
Good day everyone. My name is Jamel Dilonghai, and today I'm going to discuss the last subtopic of inferential statistics,
which is the correlation and regression analysis. So what is correlation and regression? Correlation and regression are the two most commonly used techniques for investigating the relationship between quantitative variables. So correlation and regression use different methods or techniques to identify the relationship between the given variables. Here, regression refers to linear regression. Linear regression is used to predict the value of variable based on the other variable. The variable you want to predict is called the dependent variable, while the variable you are using to predict is the independent variable. So later on, we will have an example on that the regression, linear regression um, analysis. Correlation is used to give the relationship between the variables, whereas linear regression uses an equation to express this relationship. Correlation and regression are used to define some form of association between quantitative variables that are assumed to have a linear relationship. What are correlation and regression? Correlation and regression are statistical measurements that are used to give a relationship between two variables. For example, suppose a person is driving an expensive car, then it is assumed that she must be financially well. To numerically quantify this relationship, correlation and regression are used in order for us to identify the relationship of those two given variables. So let's start first by defining the correlation. Correlation can be defined as a measurement that is used to quantify the relationship between variables. If an increase or decrease in one variable causes a corresponding increase or decrease in another variable, then the two variables are said to be directly correlated. Similarly, if an increase in one causes a decrease in another or vice versa, then the variables are said to be indirectly correlated. If a change in an independent variable does not cause a change in the dependent variable, then they are uncorrelated. Thus, correlation can be positive, direct correlation, negative, indirect correlation, or zero. This relationship is given by the correlation coefficient or commonly known as person correlation coefficient. So ngayon naman ay ituturo ko sa inyo kung paano i-compute ang person hour correlation manually. So before that, ano nga ulit, i-discuss ko ulit kung ano yung correlation. Ang correlation ay ginagamit upang malaman kung may relationship sa dalawa or higit pang bilang ng variables. Madalas, ang person hour ang statistical treatment na ginagamit para malaman ang strength at direction ng correlation. So halimbawa, may relationship kaya ang self-confidence at score sa exam. So ginagamit natin yung person hour correlation para malaman or rather yung correlation para malaman kung may relationship ba or related yung dalawang variable. So, yan. So ito yung example ng relationship. So meron tayong positive correlation. Kapag tumataas ang x, tumataas din ang y. Negative correlation, kapag tumataas ang x, mababa ang y. At no correlation, walang kinalaman ng x variable sa y variable. So yung example ng positive correlation, the longer the longer the lecture, the more you yon. So kapag tumatagal daw yung lecture, mas madalas kang humikap. And also, the more you study, the higher your test grade. So sa negative correlation naman, dito kapag 'di ba sabi dito kapag tumaas ang x, mababa din y. So example nito, the longer the lecture, so kapag tumatagal yung lecture, mas mababa the lower your attentiveness. So mas mababa yung attentiveness natin. And so another example is the more you go to party, the lower your test grade. So, ganun lang yan. Kapag tumataas yung isa or mababa yung isa. or tumataas. Kumbaga vice versa lang siya. So sa no relationship naman, um, dito walang kinalaman yung dalawang variable sa isa't isa. So paano ba natin malalaman kung positive, negative, or no relationship yung variable natin? So bago natin i-compute, mag-state muna tayo ng hypothesis. So yung null hypothesis natin is there is no correlation between self-confidence and exam scores. And yung alternative hypothesis natin is there is a correlation between self-confidence and exam scores. So here meron tayong data dito. Meron tayong table ng self-confidence, score ng self-confidence from 1 to 60, and sa exam scores from 1 to 100. So dito pa lang mapapansin na natin na may relationship yung self-confidence exam score kasi kung titignan nyo, kapag mas mataas yung self-confidence, mas mataas din yung score. But kailangan pa nating i-compute yan para magkaroon tayo ng basis. Kasi di tayo pwedeng basta-basta conclude ng conclude di tayo pwedeng magbigay agad ng conclusion nang walang proof. Yung unang step na gagawin natin ay compute ang total ng x at y. So, ang gagawin lang natin is i-add lang natin lahat ng table data ng x and y. So, kukunin natin yung summation yan. So, yung summation ng x natin is 432 at yung summation naman ng y is 720. So, yung sa next natin gagawin is i-compute natin ang deviation from the mean. So, panakuha natin yung summation ng x and y. Ngayon naman, kukunin naman natin yung mean para ma-compute natin yung deviation. So, yung mean natin sa x is, so para pala ma-compute yung sa mean, gagawin lang natin is, yung total na or yung summation, i-divide natin sa number ng values. So, kung bibilangin natin dito, meron tong 1, 2, 3, 4, 5, 6, 7, 8. So, yung n natin dito is 8. So, yung total natin is 432. I-divide natin yun sa n or sa number ng values dito. 8. Yan. So, yung mean natin is 54. So, ganun din gagawin natin sa y para malaman natin yung mean ng y. I-divide lang natin yung 720, yung summation niya, doon sa n. So, 90 naman yung sa y. So, so para ma-compute yung sa division, pumakita natin, i-subtract daw natin yung x sa mean. So, yung mean natin sa x is, di ba nga, 54. Ang gagawin natin, i-subtract natin yung 49 sa mean niya, which is yung 54. So, 49 minus 54, kaya magiging sagot is negative 5. Ganun din, sa 50 minus 54, 54, yan, so negative 4, and so on, ganun lang. Ganun din yung gagawin natin sa y. Yan. Sa y, i-subtract natin yung y sa mean niya, which is 90, minus 90, yan, negative 9, and so on. So, after that, i-multiply na natin yung division ng x sa division ng y. So, 5 times 9, negative 5 times negative 9, 45. Negative 4 times negative 2, 8, and so on. Tapos pagkatapos niyan, i-add natin lahat yan para makuha natin yung itong SP, ibig sabihin yan is sum of product. Baka parang summation lang din yan na 100. Then, isa sa step 4 naman, i-multiply ang mga squared deviations. So, dito, i-squared lang natin yung deviation ng x and yung deviation ng y. So, kap um, so yung so yung gagawin lang natin square natin yung 5 maging 25, 4, ganun, 16, -1, 1, and so on. Ganun din gagawin natin sa division ng y. Squared lang din natin. And then after that, kukunin ulit natin yung summation niyan. So summation of squared ng x is equals to 132. Summation of squared of y is 202. So after that, pwede na natin i-apply yan sa formula ng r, which is this, pero gagamitin natin dito is yung shortcut niya. Ito, wait lang para makita. Itong part na to. Ito lang yung gagamitin natin kasi ito yung shortcut niya. So, kung babalikan natin, yung SP, sum of product, is 100. Then, yung and then divide natin yan sa square root of summation of squared ng x, ito 132, lisensya. And then yung summation of squared ng y, 202, ito. Then, so compute lang natin para double check para to make sure na tama. Yan. So, ang una natin gagawin is i-multiply natin yung sa denominator. 132. Multiply natin yan siya sa 202. Yan. So, yung sagot is 26,664. Yan. So, ignore nyo lang point. Dapat kama yan. After that naman, squared natin siya. Squared of 26,604. Yan. So, yung magiging sagot is 163.3. So, tama. Laging 0.3 kasi natin, ni-round off yung 2. Pwede na, actually, dapat wala na yung square root natin kasi na-square root na natin. So, ngayon naman, i-divide natin yung 100 sa 163.3. So, yung maging sagot is 0.61. Pero hindi pa dyan nagtatapos yung computation natin kasi kukunin pa natin yung critical value. So, para makuha natin yung critical value, ito yung formula. Degree of freedom, yan, DF. DF means degree of freedom is equals to N, number of values natin, minus sa 2. Fix yung 2 ka. So, yung N natin is 8. Bigyan lang natin kanina. Minus 2, so magiging 6. So, yung degree of freedom natin is 6. Tapos, meron din tayong alpha na 0.05. So, example lang yan. So, kung titingnan natin yung table, tingnan natin yung alpha natin, which is 0.05. And then, yung degree of freedom natin na 6. Makikita natin na nagtatagpo siya sa 0.7067. After that, ikukumpara na natin yung R sa table R. So, sabi dito, kapag mas malaki daw ang R kumpara sa table R, i-reject natin yung null hypothesis. So, kung titingnan natin, mas malaki yung table R natin kaysa sa R. So, meaning, hindi natin pwede i-reject yung null hypothesis. Kasi sabi nga dito, di ba? Kapag mas malaki daw yung R, kumpara sa table R, i-reject ang null hypothesis. So, yung magiging conclusion natin dito ay there's no significant correlation between self-confidence and the exam score. Yan. So, bakit yung conclusion natin walang significant correlation yung self-confidence at exam score? Kung titignan naman natin doon sa sample data natin, obvious naman na may correlation sila. Yung explanation dyan is, hindi tayo pwedeng mag-base dun sa sinurvey natin or yun dun sa data natin, mga sagot ng data natin, dun sa research natin. So, kailangan pa rin nating i-prove yan statistically gamit yung computation. So, bakit in-accept natin yung null hypothesis? So, isa sa mga rason ay yung population. Kasi sa example natin, konti lang yung population. So, siguro kung dadamihan natin yung population, there's a chance na ma-reject yung null hypothesis. So next is the regression. Regression can be defined as a measurement that is used to quantify how the change in one variable will affect another variable. Regression is used to find the cause and effect between two variables. Linear regression is the most commonly used type of regression because it is easier to analyze as compared to the rest. Linear regression is used to find the line that is the best fit to establish a relationship between variables. So now I'm going to discuss the types of linear regression analysis, which is the simple linear regression analysis. So actually there are two types of linear regression analysis. The first one is the simple linear regression analysis. The second one is the multiple linear regression analysis. Um, but we're just going to discuss the simple linear regression analysis. So regression analysis is simple statistical tool used to model the dependence of a variable on one or more explanatory variables. The functional relationship may then be formally stated as equation with associated statistical values that describe how well this equation fits the data. So, the simple linear regression analysis, ginagamitan siya ng equation in order for us um, to predict the, what do you call this, the dependent variable. So, kung babalikan natin yung meaning ng linear regression, ginagamit siya para ma-predict yung isang variable. So, yung isang variable na yun is the dependent variable. So, ito na yung equation na gagamitin natin for us to to predict the dependent variable. So, the regression analysis equation is being used to predict the value of the dependent variable. The said equation is defined by the formula y is equals to a plus b x, where x is the independent variable, y is the dependent variable, b is the slope, and a is the intercept. So, meron pa tayong formula para sa slope and intercept. So, we use this formula para um, makuha natin yung slope and intercept. So, we have an example here. A teacher desired to know whether the typing speed of a comp sci student in words per minute is related to the time in hours. Given the speed of a student's x and the corresponding time it will take for him to learn the word processing program. Predict the time it will take the average student who has typing speed of 72 words per minute to learn the word processing program. So, sa problem na to, gustong malaman ng teacher kung related ba yung typing speed, which is the words per minute, kung gaano kabilis nila matututunan yung word processing program. So, yung speed, tinutukoy dito is yung words per minute. Saan yan? Ito, words. Yan. So, ito, tinutukoy nito words per minute. Tapos yung time naman, tinutukoy nito yung time it will take for him to learn the word processing program. So sa problem na to, ang hinahanap is yung y, the time. Kasi ang binigay niyang kasi sinasabi dito, predict the time it will take the average student who has typing speed of 72 words per minute to learn the word processing program. So, hinahanap dito kung gaano ba katagal, kung ilang minuto tatagal bago matutunan ng estudyante yung word processing program na may typing speed na 72 words per minute. So, para ma-solve natin 'tong problem na 'to, kailangan nating, i-solve first yung equation na binigay kanina, this, 'yan. So, kailangan natin 'tong i-solve. So, kung makikita niyo dito meron tayong table. Merong table for speed, ito 'yon, yung mga speed, and then yung time, minutes 'yan. Ito words per minute, ito minutes it will take them to predict. So, ang gagawin natin is um, i tawag dito, ayusin lang natin siya in vertically. I-vertically natin yung speed and time, and then magdadagdag din tayo ng another column which is the x squared and the xy. So, sa x squared, ang gagawin lang natin is yan, i-squared lang natin yung speed which is the x. Yan, 45, i-squared lang natin yung mga values dyan. And then sa xy, sa xy, i-multiply lang natin yung speed x and the time y. So, yan. Yan. So, na na squared na natin, and also na-multiply na natin yung x and y. So, ang next naman gagawin dyan is kukunin natin yung summation ng bawat column ng table na to. Kukunin natin yung sa speed, summation ng speed, time, x squared, and then xy. Yan. So, for the summation of speed, meron tayong 340. Summation of time, 443. Summation of x squared, 19,824. And summation of xy, 24,594. So, nakuha na natin yung mga summation. Pwede na natin yung ma-apply sa formula ng slope tsaka intercept. So, unahin natin yung sa slope. Or, no, intercept muna pala. A is
Thank you very much for the presenter. Actually, the presentation is very comprehensive, no? And congratulations. So thank you and good morning, everyone. Bye-bye.